And the way to solve this problem, there are two ways of solving it. This, if you want to convert this to exponential form, this would be 3 to the x is equal to 12. Now, the problem with that is that this really cannot be solved in the way that we used to, because what you need to do is you have to write this as x times the log of 3 is equal to the log of 12. In other words, you're taking the logarithm of both sides of the equation. So this becomes this becomes this. And then at this point, you would divide both sides of the equation by the log of 3. And x will be equal to the log of 12 divided by the log of 3. And obviously, if you take a close look at 3 to the x equals 12, you know that 3 to the second is equal to 9, 3 to the third is equal to 27, and therefore 3 to the x is going to be, since 12 is between 9 and 27, much closer to 9, then x is going to be between 2 and 3, but obviously much closer to 2. Okay? So that's just giving you an idea as to what this is going to be. Now, in this form, what you would do is you definitely need a calculator for this particular problem. So you need a calculator, and this is the way you would do it. All right, so try to follow me, and I hope you have a calculator handy. So you would take the log, so I would put parentheses around this. Parentheses, log of 12. So here's log right up here. You know something? Well, it's up on the top. It's just below where it says second. It says log. So it would be parentheses. Wait a minute. Parentheses, log of 12. Well, all right, forget the parentheses. So it's just the log of 12. Log of 12. You know when you're having a nightmare and the nightmare doesn't end? That's what, no offense, the best part was talking to you between 1 and 120. But ever since then, everything has been just going to heck. Okay, divided by the log of 3. And press equals, and you wind up with x equals 2.26186. And it goes on and on. I mean, that's not what this is equal to. This is actually equal to something which is indescribably long in terms of the number of digits. But to the nearest 10th, let's say, it would be equal to 2.3, which is, sort of close to what I was saying about, x having to be between 2 and 3, but much closer to 2 than it is to 3, and there it is, 2.3. And you can even check it by saying, well, what is 3 to the 2.3? And if you did that, you would get, so clear this, get 3, and then the upside down v to the, and in parentheses, I guess you would put 2.3. And that would come out to 12.5. Huh, what's the problem there? we're supposed to get, we're supposed to be getting 3 to the 2.3 is equal to 12, and we're getting 12.5. What's the problem? Why isn't this giving us what we're looking for, which is, 12? What's wrong with this? We can't help it. I mean, it can't come out, it can't possibly come out exactly to 12. Why not? Extra credit to the person who could tell us. So everybody's now, you can see names being moved and people guessing just because of the extra credit. All right, Karena, go ahead. Karena,
I wasn't sure if I was gonna say it because it might be a silly answer, but because it's not
hey,
a whole number, like
think
because it's a
think of
decimal.
think of what I've been going through today. Silly answers are a picnic compared to what I've been going through. Go ahead.
So because it's a decimal and not a whole number, it can't ever come out to just 12.
That's not necessarily the reason. The reason is more elaborate than that. So, Kariatu?
Maybe because it's not the exact like number, it's approximative.
Say it again.
I said maybe it's approximative, it's not exact the right number because we have 2.3.
What would give us a more accurate answer? Based on what you just said, what would give us a more accurate answer? Well, look what we did. The answer is not 2.3. That's not the answer. That's what I said we're rounding it off to. But the answer is not 2.3. The answer is 2.26186. So if we try that, let's see what happens. Let's try taking 3 and raising it to the exponent 2.26186. Let's try that and see what we get. Whoa, look at the accuracy. If you did this, 3 to the 2.26186, this is what you get. 12 point, let's see, 1, 2, 3, 4 zeros. 4 zeros, and then 1. That's pretty close. But the reason is that you had to round it off. This rounding off from 2.26186 to 2.3 gave us an answer that was pretty far off base. If we use the exact answer that we got, we still don't get the exact answer. It's still not coming out 12.000. You're still going to get numbers over here. And the reason is that the calculator is not giving us an exact answer. Even the calculator has to stop somewhere, but in reality, this should go on and on and on. If we put in 2 to the 2.26186 and then all the other numbers that are in here, which you can't possibly do, but let's say you went out like 50 places, then you get more and more accuracy. But all that said, this is a good enough answer for our purposes. Okay, this is method number 1. This is method number 1. There's a much better method of doing this problem. Method number 2. If you get a problem like this, in which you're given this question, the log of 3 to the base 12 is equal to x, you don't have to go through all this. It's not, I just did this to show you the long way. In other words, making this log of 3 equals, and all that stuff, and then dividing by it, and then you get this and it. Just by looking at this, you can immediately come to the conclusion that x is equal to the log of 12 divided by the log of 3. You don't have to go through any other thing. This is the fast way of doing it. The method is called change of bases. Change of bases. Because, you know, here you have a base of 3, and when you change it, you wind up with a regular base of 10. And if you do it now, you're still going to get the same answer, because you're still going to have to round it off, but it's a much faster way of doing it. And this is the way I recommend that you do problems of this type. Let me give you another one, and we could, you know, work on that and take a look at what I'm talking about here. So this will be problem number 2. So here's another problem. The log to the base 5 of 8 is equal to x. From here, so first of all, you know, it's good to get an idea as to what it should be. So 5 to the 1 is equal to 5. 5 to the second is equal to 25. So, you know, who knows? 8 is very, very close to 5. It's going to be a little more than 1, nowhere near 2. But that doesn't matter, because from here, you go to x equals the log of 8 divided by the log of 5. Okay, so just the way we went from here to the log of 12 divided by the log of 3, here we go from the log of 8 divided by the log of 5. And that's it. And now you just, but you still have to do the problem on the calculator. So you still have to turn it on, clear it. Okay, let's see now. So we have log of 8, close, and then divided by the log of 5. Close, close. So this is what I'm doing, just so you know how I'm doing this. I'm putting in the log of 8. It automatically gives you, as soon as you hit log, this is what it gives you. So I put in the 8. I then put in the division line, the division, and put in the log, and immediately it opens up like that, of 5, and then I just close it and put equals. That's what I'm doing. Okay, and you press equals, and you wind up with 1 point, well, you know, let's give the exact answer. X is equal to 1.2903. That's the exact answer. But if you wanted to round it off, which is absolutely fine with me, the answer would be 1.3. And that's how you do that type of problem. The log of 3, the log of 11 to the base 3 is equal to x. Solve for x. Okay, that's for you to do right now. That's all the time you really should need, because from here, you would just use the you know, the rule, the change of bases. X will be equal to the log of 11 divided by the log of 3. That's all. And now, most of the work to this problem is done by your calculators. So you know, you press clear. Mine was already on, but if it's not on, you could shut it and then press on. But it's going to be log of 11, close the parentheses, division. The division sign on the calculator turns out to be a, you know, a slanty line. So that's what you'll be seeing on your screen. The readout is going to be log of 11 and then this. So it's not a division symbol. It's a division symbol on the keyboard, so to speak. But on the actual display, it's gonna be a slanty line divided by the log of 3. And the answer is 2.18. You know, to round it off to the nearest, I don't know, the nearest tenth is good enough. So 2.18, 2.2. And that's the answer. Let's continue looking at exponential equations. And so this is the second part of that. And the second part would look like this. Here's the first problem. Let me put this problem up here. This is what this looks like. Okay. Now you don't want to do this using the same method because it's not as difficult. You don't need to use change of basis. You could, you could bring this around to there and in other words, I suppose that this problem could be done by saying x plus 2 is equal to the log of 64 divided by the log of 4, and then x is going to be equal to, since it's plus 2, the log of 64 over the log of 4 minus 2. I guess that could be done. But the better way of doing this is to just try to get the bases to be the same. Now, one of the things you really need to know is that the powers of 4, 4 to the first is equal to 4, 4 to the second is equal to 16, 4 to the third is equal to 64. You don't really have to know beyond that, but you have to know this. You have to know this. You also have to know 2 to the first, 2 to the second, know the powers of 2. 2 to the third. These are some of the things that you really need to know. 2 to the fifth, 2 to the sixth. And you also need to know the threes. 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 3 to the fourth is 81. That's about it. When it comes to 2, you should really be able to go at least as far as 64. When it comes to the powers of 3, you should get up to about 81. But when you get to the powers of 4, this is really all you need to know. So one of the things we would like to do is simply say, well, 64 is equal to 4 to the third. I mean, you could change 4 to the base 2 to a base 2 and 64, but this is much easier. Just knowing that 4 to the third power is equal to 64. Now, once you have the bases equal to each other, all you need to do is to set the exponents equal to each other. And, obviously, this is a very easy equation to solve. And, the check could be a very informal check of just kind of saying, well, 4 to the 2 plus 1 plus 2 is equal to 4 to the third, which is equal to 64, and 64 equals 64. As long as, you do something which helps you to have confidence that what you did was the correct solution. So the object to solving, let me write that. The object to solving exponential equations is to get the bases equal to each other. Okay, this is the key to what we're about to be doing over the next 20 minutes or so. The object to solving this is an exponential equation. The object is to get the bases to be the same. Okay? And, you know, it will be helpful if you know what I just wrote over here. This is pretty much what you need to know in order to, you know, solve the problems I'm about to give you, which will be representative of the problems, a type of problem that would be on the exam. Here's another problem for you to try. Whoops. Not a plus. A negative. Okay. Try to do that problem. To do this particular problem. So what I would do is just rewrite this. And then 9 is equal to 3 to the second. Right? So that takes care of the 9 part. But then you have to remember that it's not just a 9, it's also the 2x minus 3 that has to be taken into account. So the 9 becomes 3 to the second, and then the 2x minus 3 goes up there. And now, once you have the bases the same, then you can set the exponents equal to each other. So, you know, in other words, drop the bases, because you don't need that anymore. You just set the exponents equal to each other. You get x plus 2 equals, now, you know, simplify that. And I would bring over this x to there, contrary to what I usually do, which is to bring the variable to the left side, but this looked just too tempting. And then, of course, you want to bring over the 6 to this side. And 8 is equal to 3x, divide by 3. Now you can switch it around, and you get x is equal to 8 over 3, which is equal to, I guess, 2 2/3. And that's, you know, that's good enough. That's good enough. We don't have to, like, you know, create a perfect decimal. This is good enough for this type of problem. Like, this is problem number 3. Problem number 3. 27 to the x minus 2 equals 81 to the 3x plus 4. All right, let's see if you can solve that. It requires a little more work than the one we just did, but let's see if you could do that. One hint. I'm giving you one hint for this problem. To do this problem, look at this little chart over here with the powers of 3. Okay, so this is like more than a hint. This is like pointing you to the answer and saying this is how you do the problem. But that's, you know, that would be very helpful. I've just sort of pushed you in the right direction. I didn't just simply push you in the right direction here. I'm actually doing the problem, right? So 27 is 3 to the 3rd, based on what I wrote up here. 81 is 3 to the 4th, which is what I wrote over here. So this 81 gets equal to that. And then you could drop the bases. And you simply have 3 times x minus 2 equals 3. Oh, excuse me. You don't want that 3 anymore. You're dropping the bases. So this is what we're looking at now. This part of it, there it is equal to this part of it, 4 times 3x plus 4. And from there, of course, you would go to 3x minus 6 equals 12x plus 16. See, you're tempted to keep, I like positive numbers. I don't like dealing with negative numbers if I don't have to. Of course, you have to with mathematics. There's no way out of it. But I would, I would still bring the negative 3x over to there. You get 9x, and then I bring the 16 over to there. So minus 16 and minus 16, and that would give you 9x equals negative 22. Divide by 9. And now I'll turn it around. X is equal to negative. But it's very, very important. So this is the problem. Solve for x. Solve for x. And it'll be 7 to the x plus 11 is equal to 23. Let's see if you can solve that. Let's begin. So this is actually a problem where you would begin by doing this. Make believe, you're solving, you're trying to isolate the x. So you want to bring everything else to the other side. So 7 to the x is equal to 12. Now we're back to something we did earlier in the class, which was called change of bases. Remember change of bases? And the next step in this problem is to say that x is equal to the log of 12 divided by the log of 7. And then it's back to the calculator. Turn it on, clear it. Log of 12, close parentheses, divided by the log of 7, close parentheses, equals. And that comes out to 1.27 to the nearest tenth, good enough, 1.3. X equals 1.3. And if you check it, it's not going to come out because I rounded it. The actual answer in the calculator was 1.27699. So obviously, when I rounded off to 1.3, I'm losing a lot by getting rid of all these numbers. So this is really the answer, but for our purposes, that would be sufficient. Any questions? I have one last problem. And here it is right over here. Very similar to the problem we just did. So this would be 5 to the x minus 2 plus 6 equals 17. Okay, solve for x. A little more complicated than the problems that we've been doing. A little more complicated. And since we're not running out of time, but it's getting kind of close. So let me start you off at least. So let's do this. Let's bring over the negative 6. And you get 5 to the x minus 2 equals 11. And now, it's a change of base problem. X minus 2 is equal to the log of 11 divided by the log of 5. It's not as simple as the previous problem where it was just X is equal to that. This is X plus 2. So all you would do is add this to both sides of the equation, and you get that X is equal to whatever this turns out to be. And whatever it does turn out to be, you could simply add 2. Now, I'm not sure I would do that all in one step with the calculator. I think what I would do first is this, and then add the 2 afterwards. But let's check it out here. Log of 11 divided by the log of 5 equals 1.4. I'll go with 1.5 and then plus 2. So 1.5 and then plus 2, and X is equal to 3.5. And that's the answer to the question. So in other words, in doing this problem, you're first bringing the 6 over, then it becomes a change of base problem. And you make that the change of base, but then you have to bring over the 2. So I figured out what log of 11 divided by log of 5 is, and then I simply added 2 to it, and I wound up with 3.5. And now I think I've covered every single thing that will be on the exam. So now you are free to go back to the practice test that you may have looked at before and begin in earnest to prepare for the exam by doing the practice test in time for Thursday's class. Okay, so I will see you then.